Here we go with Unit 3, Lesson 8 homework help today. Start this assignment, 5 problems. Talking about working with the equation y equals mx plus b. We're talking about slope and y-intercept. Before I get going on the lesson, I just wanted to remind you that we have the formula for what we call slope, intercept, form is y is equal to the slope m times the input x plus, could be minus, the y-intercept. Remember that the two important pieces that are constantly changing are are not changing, are m and b, and that's why these two numbers are so important. This is actually why we call it the slope-intercept form, because the slope is known and the intercept is also known. In this first question, we're seeing that we need to select all the equations of the graph that have the same y-intercept. So we're really focusing just on this part, the ending of the equation, no matter what the ending is. We are looking at the ones that have all the same ending here. I want to look here. There's a -8, a -9, a +8, a -8, a -8, a -8. There's a lot of -8s in there. So I would have to say that this one is out because it doesn't have a -8, and this one is out because it doesn't have a -9, and we're left with all these ones that have the exact same y-intercept. Sometimes what we'll hear about the y-intercept is it's also called the constant, and we only call it a constant. Don't be confused with constant rate. It can't be a rate because it's sitting isolated all by itself. It's constantly that single value. So there's that one. Oops. Question 2. I have a couple of graphs here that we are going to compare. Select the graph that correctly shows the equations y equals 1/4 x and y equals 1/4 x minus 5 graphed on the coordinate plane. Going back to what we just talked about a moment ago, talking about the form y equals slope, the y coordinate is equal to the slope times the x coordinate plus minus the y-intercept. So as we look at these two equations, what we notice is that they both have 1/4 as the slope. So these two lines will be parallel. And then we need to understand the last part of this for one of them. We see first off that there's only one graph with there that can be proportional. We have this one graph right here that is proportional. But this graph also has one that's parallel to it that has a -5. Now you'll notice that this line right here, graph B, the lower line passes through -5, and graph A, the lower line passes through graph -5. And so we have to recognize that these two graphs, both of them, can represent here. So the real question is, which graph represents y equals 1/4 x? Knowing that y equals 1/4 x is a proportional relationship, so we could actually start to extend this to say that I know that this equation, 1/4 x, passes through 0, 0, or has a y-intercept of 0, 0. So make all your answer selections down here below that will appropriately work with this. Which one of these graphs correctly shows, right here, correctly shows the equations? So is it graph A or is it graph B? And then complete the statement about the graphs, talking about the slopes and talking about the y-intercepts. This one we have to think a little bit without using a picture. If you need to draw a picture, draw a picture. But for this question, it has two different parts. First part A, then part B. In part A, we see that a cable company charges $70 per month for cable service to existing customers. Complete the linear equation representing the relationship between X, the number of months, and Y, the total amount paid in dollars by an existing customer. Well, for this first one, we're seeing that $70 per month, if X is the number of months, then that would be $70 times any number of months that's given. So in this case, we simply need to enter 70. For new customers, right? This was for existing customers. Now for new customers, there's an additional one-time, that's kind of a big deal, an additional one-time $100 service fee. So what's the difference here? Well, existing customers, and it looks like the plan here is $70 a month, so our slope can't change. we know that our slope is equal to $70 a month. But we have this other thing right here, our initial value, or our initial cost, is that plus $100. So we're not only paying $70 a month, we're also paying $100 one time. So think about the relationship between these two equations. The slope, obviously we're paying the same amount, so the slope right here should be the same amount, but we need to put that initial cost in here as well, decide what the order is, and then complete the statement about how the two equations are related to each other. And under the geometry of this thing, think about what happens when two lines have the exact same slope. What do they look like? Will they ever intersect? That kind of stuff when you're looking at this next one. Problem 4 gets us into a little bit of review back from lesson 6. A mountain road is 5 miles long and gains elevation at a constant rate. Kind of a big deal right there. Constant rate tells me we have a straight line, which means we do have a slope. After 2 miles, the elevation is 5,500 feet above sea level. After 4 miles, the elevation is 6,200 feet above sea level. Find the elevation of the road at the point where the road begins. Well, here's what we know about this road so far. I think a table might be a good option for us. If we talk about X and we talk about Y, and we'll talk about X is the number of miles, and then Y we'll talk about elevation. What we know is that at 2 miles, the elevation was 5,500 feet. And then after 4 miles, we knew that the elevation was 6,200 feet. And then the question is, what was our elevation at the beginning of the road? So we need to go backwards 2 miles to be able to figure out our elevation. Well, how do we do that? We have a couple of options, but both those options have to start with finding the slope. The slope, moving from 5,500 to 6,200 feet, is a gain of 700 feet over 2 miles. Now, since this road is increasing at a rate of 700 feet for every, oh my goodness, it's increasing at a constant rate, we know that the slope right here is 700 feet of elevation for every 2 miles. We could also say that that's 350 feet of elevation per 1 mile. Now we need to work our way backwards to the sea level. So maybe what if we thought about our table? Let's go ahead and give ourselves just a little bit of room. If we're looking at this as a table, as a value, we need to go ahead and go backwards to 0 miles on the road. So if we're going backwards 0 miles, this is a decrease of 2, meaning that this opposite direction should be following the slope, a decrease of 700, just working backwards. And that will tell you where your elevation above sea level would be. If we complete the statement that describes where you would see the point part A on the graph, where the Y represents the elevation in feet and X represents the distance along the road, that point would be, well, we know it has to be 0 miles. And then that blank space right here, that's going to be associated with the elevation right here. Remember that elevation right there is 700 miles less than 2 miles up the road. And it's located on which axis? Remember that we're looking for this right here is the y-intercept. So which axis will that actually be on? Final question. Match each graph to the situation. When we look at our graphs here, we see graph of A, graph of B, graph of C, graph of D. What I'm going to suggest before we even look at these situations a whole lot is that we need to recognize 2 major things from this lesson. What is the slope? What is the y-intercept? So let's look at our 4 graphs real quick, and let's go ahead and identify slope and y-intercept for each graph. And I believe that that will really help us as we get going to look at the next ones. Graph A, our slope, if we look at our points, here's one right here, here's one right here, here's one right here. Let's go ahead and find that slope. We see that there's a rise of 1 and run of 1, 2, 3, 4, double check it, rise 1, 1, 2, 3, 4. Awesome. Slope of 1/4. Where did we begin? Well, if this is 5, there's 6, 7, and 8. So we have an initial value, or check this out, B. I have this little thing that I use to help me remember. It's kind of like a mnemonic. Let's talk about the B first, though. Is at 8, so our y-intercept is at 0, 8. Here's what I think about when I'm writing any equation. I know that x and y are always going to be changing because they're the input and the output. There are lots of different points on the line. But when I think about this, not only is the m the slope, but it's also how we move across the graph. So we move by rising and running across the graph. A way that something we can think about B is where we begin with the line. Now, especially when we're talking about real life situations, we always begin on the y-axis. So if you just take that into account, I think it will help us think about part B. I begin right here at 3, and I move to my next point by rising 2 and running 1. And then that should be able to help me to figure out really quick and easy that y equals my movement times x plus where I began, because it's a positive number. Take a look at part C. I begin at 0, and then I move by going up 1, 2, 3 to the right 1, 1, 2, 3 to the right 1. There you go. So my movement is units of 3 over 1, which gives me the equation y equals 3 times x plus 0. This is a proportional relation, and 0 plus 0, there isn't any benefit to actually putting that on there. So we could leave that there, or we could just erase that. That's why it's highlighted. So the final problem right here, I want to leave this one to you to figure out on your own. But what we do with these pieces now is we need to recognize where they are at. We know what the slopes are. We know what the y-intercepts are. And so what we can do with these is we can go ahead and go down here with graph A. I have to clear this off. Graph B, the number of chapters read y after x days, the slope of the line is 5/4. Well, that means we're going to have to rise 5 and run 4. So which of these up here with D, C, B, or A has a slope of 5/4? Well, if memory serves me right, we didn't talk about a slope of 5/4, so that might be the same as the graph we didn't talk about. This graph shows the cost in dollars, y, of a muffin delivery and the number of muffins ordered. The slope of the line is 2. So going back to these, which one of these had a slope of 2? We know that B had a slope of 2 because it was a rise 2, run 1. So we could just take that one right there and plug it in for B. Kind of get the idea here, read through the situation. The slope is given in each of the situations. Match up the slope to the graph and you're all set. That's it for your homework. Let me know how I can help.